This is Precalculus, lesson 1-2. We're talking about solving sinusoidal equations. All right, so we need to talk about some properties first. So deriving properties. We have this graph, sine of x, graphed below, and we need to graph this y equals 0.4 function. So right now, go ahead and graph y equals 0.4. And it doesn't have to be perfectly straight, but it should look something like that. Do we all get this rough graph? Yes, no? Nice. Okay, so notice that it intersects the graph of sine x at 4 points. Let's go ahead and label this point right here A. This point right here is going to be B. This point right here is going to be C. And we don't need this point, but we're just going to label it D for the heck of it. Cool, cool. Now notice point C. Point C is repeated in terms of the direction that the function is flowing through it. It's coming from this downward position. You don't need to write this down. I'm just kind of writing because you can't see my mouse. In fact, I should probably turn that program on. Anyway, it's coming down through it. Where does that happen again? Is it A, D, B? What other point is it coming down through C? Somewhere on here? Is it somewhere?
Sorry, boss, where you are.
So the function flows down from the top left to the bottom right through C. Where else does that happen at the same height? On which letter?
D.
D flows from the bottom left to the top right. I'm looking for something that flows from the top left to the bottom right.
That's B.
So it's B, yeah. And notice how far away B is. How far away is this x-coordinate from this x-coordinate? Or even better yet, how far is this point that flows through 0 away from this point that also flows through 0? So let me re-ask that question.
Can I turn on the lights because I can't see?
Yes, please do. And I'm going to turn this on also. I don't know why my pen attention is not... There it goes. All right. So asking the question, if I go through this point 0 from the bottom left to the top right, where else do I flow from the bottom left to the top right that goes through this height of 0? Happens over here. How far away is this point from this point in terms of the x-coordinate?
2 pi.
2 pi. It repeats every 2 pi. So we have the following function. And I'm going to do the left-hand side in blue, the right-hand side in green or something like that. This is going to be in radians. So I can say that cosine of theta, that's kind of like our x, is the same height. So this height at any theta is the same height as cosine of that theta shifted over 360 degrees. I'm not going to end my parenthesis yet. Don't end yours either. But that works for another 2 pi. If I come out here to 4 pi, it will also have a height of 0. If I go negative 2 pi, that also has a height of 0. To account for the fact that you can multiply that 360 degrees by any number, any integer, full number, we say multiply by n. So just times by n. And we'll note out here, note n is an integer. I'll actually spell that out. Integer. Let's do that in radians. So this formula in radians looks like this. Cosine of theta is equal to cosine of theta plus what? What's 360 converted into radians?
3 pi over 2.
Close. And it's just right here, right?
Oh, it's pi.
2 pi. 2 pi radians. So 2 pi times n. So you can always add 360 degrees or always add 2 pi depending on if you're in radians or degrees. So far so good? Okay, this is where these labels actually come into play, where A and B are a certain distance apart. So go ahead and mark this up on your graph up here. This distance right here, I'm going to call that distance theta. Notice that this distance from the x-coordinate of B to pi is also theta. Kind of interesting. It has that symmetry to it. So if theta is our normal degree, so we can say, oh my gosh, I did cosine for all these, didn't I? I apologize. It should have been sine. This is a graph of sine, not cosine. Sorry about that. This should say sine, switch to green. This is going to be sine and sine. Go back to blue. So we're going to start these the same way. Sine of theta. If I have a height at theta, obviously every 360 degrees I'm going to get to that same height. But another shortcut for kind of jumping through the symmetry is I go to pi and then I go backwards theta. I'm going to repeat that again because that's the crucial step for right here. So I went theta and I got to a height of A. Another way to get to the same height is I skip to pi and then I go backwards that same theta, that same principal value. So this sine theta is equal to sine of, it's going to be sine of, well, what's pi in degrees? 180. So we skip to 180, and then what do we do next? We went to 180. Where's my mouse? Then we did what? No, we went backwards by how much?
By pi.
By this guy, right?
Yeah.
So that's theta. So we're going to subtract theta. Let's go ahead and write it in radians.
What's the definition of theta?
Theta is like an x. I can write it off here to the side if we want. So
Yeah, I was kind of confused. I was like,
theta is like an x, just a variable,
okay.
for degrees.
Isn't there other one as well? Theta.
I guess measure of an angle is more accurate because it could be radians or degrees. Okay, so now we need to convert this one into radians. So sine of theta is equal to sine of, now I have to convert 180 degrees, and this is actually matching the picture, so it should be a little bit easier. I skipped to pi, and then I went backwards by theta. So how do I write that here?
Pi minus beta, or beta.
Pi minus theta, yep. There it is. I don't really want to skip over this because it's kind of important, but this is the same rule as this rule up here. And by the way, this rule, we should probably do a red star. This is one of the 2 rules you really need to know from today. I assume that you know that sine repeats every 360 degrees. So that's why I'm not going to start. We already did that in our last lesson. This is our new one. This one is essentially, this next rule that I'm about to go over, the third one, is the same as the second one, but it's just 360 degrees away. So if you did everything in here, subtract 360, what's 180 minus 360? 100. Say it again?
180. 180.
Yeah, so essentially what I'm saying is sine of theta is equal to sine of negative 180 minus theta. All I did was I took this rule and I subtracted 360 because I'm allowed to add or subtract as many 360s as I want, and I'll still get to the same height. And the picture explanation is kind of cool too. So to get to theta, I went from 0 and I went positive theta. Another way to get there is I skip over here to negative pi, or to negative 180 degrees, and I go another negative theta, because this distance right here is also theta. So that's the picture representation of this rule. It's not that important, so I'm not going to spend too much time on it, because it's essentially this rule, but applying the first rule to it. Let's convert this into degrees just for our notes, and then we'll move on to the next graph. Sine of theta is equal to sine of what? Convert negative 180 degrees into radians. Negative pi minus theta. There it is. So far, so good. So right now they're just rules in our head. We're going to get some practice in here on the back side of the paper. Okay, same thing. Graph y equals 0.4. Let's label that we only need 2 intersections for this one, just A and B. A is going to be on the right, B is going to be on the left. This is going to be very similar to what we just did for the first step of our graph of sine. So this is going to be a cosine. It's actually a cosine this time. Cosine of theta is equal to what? We can always find the same measurement 2 pi away. For example, the height at 0 is 1. The height at 2 pi is 1. The height at negative 2 pi is 1. The height at 4 pi is 1. The height at 100 pi is 1. All those were divisible by 2 pi. So cosine of theta is equal to cosine of theta, but you can always add a multiple of 2 pi, or a multiple of 360 degrees. 360 degrees times n. Again, n is assumed to be some whole number, some integer. Positive or negative, it doesn't matter. Can someone help me convert this one into degrees? You want to try it, Daisy? You want to try converting this one into radians? Change that 360 over to something else?
So it would be like cosine theta, yeah, equals cosine theta plus 2 pi?
2 pi n, yep. Very nice. All right, now we're actually going to use the picture. And this is the easier rule to remember, but again, this is going to be, we'll do a red star here. This is kind of important. Which is this. If I look at that height at theta, so the height here is 0.4. This distance right now, go ahead and mark this on your graphs right now. This distance in the x direction is our new theta. This distance. Notice how to get to this distance b. It's the same distance from this x-coordinate, theta. So how do we say that? Cosine of theta, how do we get to this other height? This one was a positive theta, this one was a negative theta. What do I write here? To get to the same height, I take cosine of what?
Beta.
I don't know. I'm just going to write what you write. Cosine of theta.
You're trying to get from 0 to b, right?
Yeah, how do I get from 0 to b?
So it'd be beta minus.
Well, you're starting at 0, right? So we want to say 0, and then you go this distance. So it's 0
0 minus theta?
theta, yeah. So what's 0 minus theta simplified? It's just negative theta, right? Yeah, so this one is just negative theta. And this is kind of a cool property. It happens because this function is even. Even is just a fancy way of saying that if this was a piece of paper and I folded it across the y-axis, that the function would line up if I held it up to the light. So it's even, therefore we have this rule. All right, let's try to use these rules now. There's 2 examples from Khan Academy. So flip over to the back of your paper. And by the way, the reason that we didn't have to convert into radians is because we didn't have 360, we didn't have any pi, so this works for both radians and degrees. Example 1. All right, so reading the instructions is pretty key here. So we're selecting one or more expressions. We're choosing all answers that apply. So you can select A and B, A, B, and C. It can be multiple answers. And the other key part here is we are in degrees. It'll always tell you if you're in degrees or radians. All right, so we have our laptops at the ready. We're going to need those. Go ahead and open those up. When you open up your laptops, let me make this within the view of what's going on. We're going to go to Desmos. So make sure that you are in degrees, not radians. By default, this is in radians, so click on degrees. And we're going to solve for this one. So we have sine is equal to negative 0.7. So how do I undo sine? We've been talking about these inverse functions. To undo sine, this is what you do. And go back to your notes here. Go ahead and write this down. We're going to take the arc sine. So sine to the negative 1 of all of this, and we do the same thing to both sides, is equal to the arc sine, or sine to the negative 1, of all this. That means that to get x by itself, arc sine and sine cancel each other out, and I'm just left with x. I want to pause here.
I'm confused with the homework last night because of the negative 1. I didn't know what I was supposed to do, but nothing.
Right, yeah, so arc sine of negative 1, I think I said that arc sine and arc sine to the negative 1 are the same thing?
Yeah.
Yeah, you're okay with that? Okay.
I was just really confused. I didn't know if I was supposed to distribute the negative 1 at first. I was like, wait.
Oh, yeah.
Doesn't make
So
any sense.
it just, yeah. You get it now, though?
Yeah, I get it.
Perfect.
Yeah.
All right, so arc sine and sine cancel each other out. It leaves us with an x that is isolated. And on the right-hand side, we have arc sine, or sine to the negative 1, of negative 0.7. So now we need to use our calculator to figure out what this is. So arc sine of negative 0.7, if we come back over here and we type in, literally, arc sine of negative 0.7, you should get negative 44.43, rounding to 2 decimal places. Do we get that? So x is equal to negative 44.43. And that's in degrees, yeah. All right. So that is one answer, but notice that all these answers over here have n's in them. This is using that first rule that we learned all the way up here at the top. It's using this rule right here, where you can add on 360 degrees. So coming down here, we can always add on, so we can always add 360 degrees times n, because you can, and you assume that n is an integer. I think it even says that. Yeah, assume n is any integer. And that will get you a lot of the values. This will actually get you half of the values. Do we see this in our answers? It's C?
B.
Oh, it's B? Yeah, I agree it's B. But there is another answer, and how do we find it? The answer is you use this second rule, the starred rule. We do 180 minus whatever we got. So come down here.
Why do you do that?
The reason is, I mean, graphically, it's because we just found A, but we need to be able to find B. 360 degrees plus or minus A will get you all the way over here. It will get you all the way to D, but then you'll be missing values of C and B. And algebraically, your answer is because you can apply that rule to find the second half. So I'm going to come down here. X is going to be equal to 180 degrees minus whatever the angle was that we just found. Our angle was negative 44, so we're going to have this double negative. 180 degrees minus is the formula, and here comes our angle. Our angle was negative 44.43 degrees. All this is in degrees. I usually just do units at the very end. So double negative, when negatives kiss, they become both positive. And that's going to be, can we do this in our heads? 180 plus 44, and then worry about the 0.43 later.
Could be 224.
224.43 degrees plus 360 degrees n times n.
Why'd you add 360 but not 10 then?
Yes, good question. See if you can answer it yourself. Why did we do that? Daisy, have an answer?
What's that? Oh.
No? It's from that first rule that you can always add 360 degrees times n. With every single measurement that you find, it's always repeated 360 degrees later.
But can you do it with 180? Or
Even after you apply this rule, you can still apply this rule on top of it, yeah.
So basically when we found what x is basically data, right?
Yeah.
So then since we found x, you added the 360.
Yeah, you keep adding 360 degrees to find that one. And then to find the second half of them, remember, we only found the first half of them. By doing that first half, we found A, we found D, we found E over here, I guess. But we weren't able to find B and C. To find the B's and C's, we had to use that other formula right here, 180 minus that, to find it. Does that make sense so far? So this formula will get you the second half, this formula will find the first half. Notice that that isn't an answer, though. There's no 224.43 plus 360n. If it was, that would have been an answer. So what we're going to do is we're going to just do this number and then subtract 360 degrees. Again, you're allowed to just subtract 360 degrees however many times you'd like. So I'm going to use my calculator to make sure I don't make a mistake. And I'm just going to do this, 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 and this. So I'm going to do 360, well, actually it should be 224.43 minus 360. I should have just used my stylus. And it's negative 135.57. Let's write that down. Negative 135.57. Negative 135.57. And again, you can always add 360 degrees. Oops.
Why did you subtract 360?
You're allowed to subtract and add as many times as you want. We're going to see if we can find this answer somewhere in the multiple choice answers.
A.
It's A, yep. Cool. I want to check this graphically too. Graphically what this looks like, and you don't have to do this because we're running low on time, but this is how you do it graphically. You actually type sine of x, and then I'm going to change my step here. My step is going to be 90. I'm going to change this from like negative 720 to 720. We'll change this from negative 1.1 to 1.1. And then I'm going to also graph what is looking for. So we were trying to find sine, and we also wanted to find y equals negative 0.7. Those were the two functions that we're looking for. Notice that our first answer was negative 44.43. That's exactly where this is. Negative 44.43. Bam, it was right there. And then when we add on 360, you get this answer. You get this answer. You get this answer. But we were missing half of them. We were missing the half when we looked over here. Negative 135, 224. Those were in our notes. Negative 135, 224. Those were these two numbers. Those were our starting values, and then every 360 degrees, we'll find an answer. Does that make sense graphically now too? Nod our heads. We're okay? All right, so the answer was just A and B. Let's do example 2. This one is going to be quicker because I'm going to show you the shortcut. Are you ready for example 2? On our laptops, graph whatever function is looking for, cosine. So go ahead, you have nothing here. Go ahead and graph cosine of x. Change your axes so they look roughly like mine. So this is going to be negative 1.1, 1.1, negative 720 to 720, step by 90. Look roughly like that. And these are things you're just going to have to hopefully memorize to make it easier on yourself.
This step is what?
90.
What's the x-axis? It's
Negative 720 to 720.
okay.
Actually, for this one, can we make it negative 720 to 1100? So 1100. Okay, so we're graphing cosine, and then we're going to also graph 1. We're going to figure out where they intersect each other. So notice our problem. Our problem said cosine of x is equal to 1. Graph them both and see where they intersect. I'm going to graph 1 now. Y equals 1. Where do these intersect? Notice that it intersects here at negative 360, here at 0, here at 360, here at 720, and here at 1080. So, our answer. Which of these are answers? Help me out. Which of them were answers according to our graph? 360 was an answer. And it says choose all answers, so there's probably multiple. What's another one? 720. 540. Did you click on these points up here, Rochelle?
Oh, they're up.
Any other answers?
1080.
1080 and 0, right?
Yeah.
Here's the problem with those. It's this guy right here. Yeah, so when I first did this problem, and even in my recording, my last time, I said 0 and 1080, but that's actually not correct because it's not in the interval that they ask for.
So it all depends on the limit where it should be.
The boundaries, yeah.
Yeah.
So there's your answer. All right. So I just showed you a shortcut. That shortcut will actually work for this function as well. For this function, the shortcut is graph sine of x, graph y equals negative 0.7, click on the points that they intersect and see where those beginning points are. Know that you're always multiplying by a factor of 360, never by 180. There is a trig function that multiplies by 180. Do you remember what it is from our notes yesterday, or notes last time? It wasn't sine, it wasn't cosine, it was tangent. Tangent repeats every 180. But they will never ask sine, or they will never ask tangent on this problem set, so don't worry about it.
The final?
No, I don't think it will. All right, that concludes today's notes. Any questions? Go ahead and write your summaries.